your test is on sections 4.1 and 4.2. It goes over everything that was on your quiz as well as what we went over in 4.2 additionally. So literally your quiz that you had for 4.1, every single type of question that was on there is going to be on your test as well. Okay. You're going to need your calculator for this. So make sure you have it. You cannot use your phone. You cannot borrow somebody else's calculator. It has to be your own. So make sure, like I said, you have it. Your first question tells you to evaluate each function for the given value, round to 3 decimal places if necessary. For number 1, you have f of x is equal to negative 5.2 to the power of 3x. For a, we're using negative 0.94x, so it's going to be negative 5.2 to the power of 3 times negative 0.9. If we round to 3 decimal places, we are going to have negative 0.012. What I expect tomorrow for your test is that you're actually giving me negative 5.2 to the power of 3 times negative 0.9. For B, you have negative 5.2 to the to the power of 3 times 3.4. So again, we're going to write down what we put into our calculator. And then round to 2 decimal places if we need to. For this one, it does not need to round. It is a whole number. So this gives you negative 201,01761. So that's negative 20,101,761. For C, we're going to have negative 5.2 to the power of 3 times 4/9. So negative 5.2 to the power of 3 times 4/9 gives you negative 9.008886, so on. So you're going to round to 3 decimal places, and that is negative 9.009. For number 2, you have f of x is equal to 9.7 times e to the power of negative 0.3 times x. For a, we're plugging in 0.58 for x, so that's going to give us 9.7 times e to the power of negative 0.3 times 0.58. So again, we write down what we plug into our calculator. Put it into our calculator. You're rounding to 3 decimal places. And this would give you 8.151. For B, you're plugging in negative 3/7 for x, so it's going to be 9.7 times e to the power of negative 0.3 times negative 3/7. So again, use your calculator. And it's going to give you 11.031. For C, you're plugging in negative 4.91 for x. So it's going to give you 9.7 times e to the power of negative 0.3 times negative 4.91. So again, you plug this into your calculator, round to 3 decimal places. It gives you 42.314. Your next section asks you to state whether the function has a growth or a decay. Remember with these, what you're looking at to tell whether or not there's a growth or a decay is the part that is in parentheses. It's the number. If the number is greater than 1, it's a growth. If it's less than 1 but greater than 0, it's a decay. So with these, for number 3, you have f of x is equal to negative 2.9 times 3.14 to the power of 4x. That 3.14 is what you're looking at. So 3.14 is greater than 1. This means that there is a growth. For 4, you have f of x is equal to 5.4 times 0.29 to the power of negative 9.2 times x. The 0.29 is what you're comparing to 1. It is less than 1, but greater than 0. So this one is a decay. For 5, you have f of x is equal to negative 5.3 to the power of 5/3 x. The 5.3 is what you're looking at. It is greater than 0, or sorry, greater than 1. So you have a growth on this one. And then with 6, you have 6 times 0.994 to the power of negative 4.5 times x. 0.994 is less than 1, but greater than 0. So we have a decay on this one. For 7, you have a total of $8,340 that's invested into an account that earns 7.38% interest compounded quarterly. You're finding the amount in the account after 10 years. So this means quarterly, you're going to use A is equal to P times 1 plus R over N to the power of N times T. Your P is your principal. That's that 8,340. Your R is your rate as a decimal. So that's the 7.38%. Turn it into a decimal, and it's 0.0738. Your N is the amount of times it's compounded. It's quarterly, so that means it's 4. And your time, T, is after 10 years. So plug all this in. You have 8,340 times 1 plus 0.0738 over 4 to the power of 4 times 10. You are dealing with money with this. So when you type this into your calculator and get the number that's your answer, you have to make sure that you round to 2 decimal places. Because like I said, you're dealing with money. If you don't round to 2 decimal places, you're going to get points taken off. So like I said, make sure that you're aware with these interest questions, you're working with money, so you're rounding to 2 decimal places. It should be automatic. So if you plug this into your calculator and round to 2 decimal places, you get $17,328.24. For your next question, it tells you that you have a total of $72,000 that's invested into an account with an annual interest rate of 3.72%, compounded continuously. Find the balance in the account after 5 years. So since this is continuous, you're going to use A is equal to P times E to the power of R times T. Your principal is the $72,000. Your rate is the 3.72%, which gives you 0.0372. And then your time is 5 years, so that's 5. So you are going to have 72,000 times E to the power of 0.0372 times 5. So once again, you're working with money. So you are rounding to 2 decimal places. So when you round to 2 decimal places on this one, you get $86,718.40. For your next problem, you are completing the function table and graphing the function. You're given the function f of x is equal to 4 times 1/2 to the power of x. Your x values are -2, 0, 2, 4, and 6. So this means that you're going to have 4 times 1/2 to the power of -2, 4 times 1/2 to the power of 0, 4 times 1/2 to the power of 2, 4 times 1/2 to the power of 4, and 4 times 1/2 to the power of 6. You can use your calculator with these if you'd like to. Some of you won't need to, but like I said, if you want to, you can. For the x value of -2, you have 4 times 1 over 2 to the power of -2, which gives you 16. Then 4 times 1/2 to the power of 0 is just 4 times 1. So that's 4. 4 times 1/2 to the second power is 4 times 1/4, which is 1. 4 times 1/2 to the fourth power gives you 1/4, so that's 0.25. And then 4 times 1/2 to the power of 6 is 1/16, which is 0.06 if you round it to 2 decimal places. So if you graph these, your first order pair is the -216. So -216 is going to be here. Then you have 0, 4. So 0, 4 is here. And then 2, 1. 4, 0.25. And then 6, 0.06. So with this one, you're going up as you go to the left, down as you go to the right, but that line is not going to touch that x-axis. Your next section comes from going back and forth from log form to exponential form or exponential form to log form. For 11, you are writing the expression or equation in log form. So you have 5 to the -3rd power is equal to 1/125. Remember with this, you're going to drop that 5 down to become your base. The -3 becomes your answer. The 1/125 becomes your big number. And you add the word log into there. So you're going to have log 5 of 1/125 is equal to -3. For something like 12, you have 6 to the 4th power is equal to 1,296. So again, that 6 is going to drop down. 4 becomes your answer. The 1,296 just switches spots. So you're going to have log 6 of 1,296 is equal to 4. For 13 and 14, you're writing the log equation as in exponential form. So remember with these, you're going to drop the log, bring up your base, switch the big number with your answer, and then you're done. So for number 13, you have log 7 of 343 is equal to 3. Your log is going to cancel out. You're going to bring up the 7. You are going to move the 3 over as the power, and then on that 7, and then that it's going to be equal to that 343. So you're going to have 7 to the 3rd power is equal to 343. For something like 14, when you have log 4 of 4,096 is equal to 6. Again, drop the log, bring up the 4. 6 becomes your power. Your answer becomes the 4,096. So you have 4 to the 6th power is equal to 4,096. Your next section tells you to evaluate each log. With these, remember, if you don't have a base, it's 10 automatically. You may want to use prime factorization with them as well, because some of them are going to be bigger numbers, so you're going to take your base and use that as the number that you're dividing by. However many times that number, as your base goes into the big number, is your answer. So for 15, you have log 3 of 81. So that means 3 to what power is equal to 81. If you don't know off the top of your head, you can take 81 divided by 3. 3 goes into 8 twice with 2 left over. 3 goes into 21 7 times. So that's 3 times 27. The 27 is 3 times 9. 9 is 3 times 3. So your 3 is there 4 times. That means it's 3 to the 4th power is equal to 81. Your power is your answer on this. So 4 is your answer for number 15. For 16, you have log of 10,000. You don't have a base on here, so it's automatically a 10. So you're saying 10 to what power is 10,000? You have 4 zeros here, so that's 10 to the 4th power is what's giving you the 10,000. So again, we say our power is our answer. 4 is your answer on this one. For 17, you have log 2 of 1/64. So 2 to what power is 1/64? You know it's going to be a negative because it's a fraction, so the reciprocal was taken. So that means take the 64, find the prime factorization of it. It's 8 and 8, but the 8 is 2 and 4. 4 is 2 and 2. So you have 1, 2, 3, 4, 5, 6 2's. So that means it's 2 to the negative 6th power gives you 1 over 64. That negative 6 is your answer. Your next section tells you to use the properties of logarithms to solve. For 18, you have log 5 of 36 is equal to log 5 of x. Remember, if you have the same log with the same base on both sides, they cancel each other out. So these cancel, and you have that x is equal to 36. For something like 19, where you have x is equal to log 9 of 9, your base is the same as the whole number, so log 9 of 9 cancels out to be 1. So x is just equal to 1. For 20, you have log 7 of 7 to the power of 31. Again, your base is the same as your big number. At the same time, when you have a power on your big number, that power goes to the front. So we could say this is 31 times log 7 of 7. The log 7 of 7 is just 1, so 31 times 1 is just 31. For 21, you have 3 to the power of log 3 of 14. Your base is the same as the base on the log, so these cancel each other out, and you're just left with the 14. Your next section, you're going to need your calculator for again, and you're just evaluating the natural log functions. So again, use your calculator, plug in what's in the parentheses for x, and then simplify. Again, round to 3 decimal places if necessary. So for this one, it's just ln of x. You might see it as something like 2 times ln of x, 4 times ln of x, something like that. But for A, you have f of 6.34. So again, write down what you're plugging into your calculator. So that's going to give you ln of 6.34. So that means that you have 1.847. For B, you're going to take the natural log of negative 4.7. With this one, you cannot take the natural log of a negative number. So because there's a negative in here, you shouldn't even have to use your calculator. You can just give me no solution. For something like C, where it's the natural log of 9.2, this is going to give you 2.219. And then for D, you have f of 4 plus the square root of 5. So that's the natural log of 4 plus square root of 5. Should give you, here, let's write this down. Natural log of 4 plus the square root of 5. Rounded to 3 decimal places, 1.830. For E, you have 0.48, so that's the natural log of 0.48. Rounded to 3 decimal places gives you negative 0.734. For your last section, you are using the properties of natural logs to rewrite these expressions. For 23, you have the natural log of 1. Remember with this, when you're taking the natural log of 1, it's automatically 0. So this one is going to be 0. For 24, you have the natural log of e to the power of 7.3. The natural log times e cancel each other out. You're just left with the power, so 7.3. For 25, you have 13 times the natural log of e. These cancel to where it's just 13. And then for 26, you have e to the power of ln of 24. Those two cancel to where it's just the 24.